Bandwidth for First Updates Now is supported by the Blue Alliance. Keep up to date on all live and archived First Robotics events and team stats at thebluealliance.com. First Updates Now is brought to you by Twitch. Fun is now a Twitch partner and offering some awesome subscriber-only benefits. Subscribe today or get a free subscription each month when you have Amazon Prime by linking your account and clicking subscribe. Good evening, everybody, and welcome to a very special presentation of First Updates Now. This is our second of our four-part series. It's time to get down to the fundamentals of LabVIEW, where you can get the inside scoop and expertise of how LabVIEW can help your FRC team. I'm Tyler Rolds, and we got some awesome prizes for you tonight if you are tuning in. We hope you're excited for that as well, courtesy of National Instruments with a fantastic RoboRio, and we'll talk about some trivia in just a little bit. Well, enough about me. Let's bring in the people who actually know what they're talking about with this subject a little bit. I'd like to welcome in a fantastic person from National Instruments down in Texas. Please welcome April Riddett to the show. Welcome back, April.
Hey guys, thanks for having me back. Like Tyler said, my name's April. I work here at NI. I've been here for about 2 years now. I also volunteer with First. I mentor a team. I also CSA events, and I'll actually be an FTA in Texas next year. So hopefully I know what I'm talking about.
Hopefully we'll figure that out as we go through. And chat, don't be afraid to call her out for anything, of course. So, April, by the way, as we mentioned, this is our second of four-part series that we're going into and taking a deep dive into LabVIEW, which is a great option for FRC teams to use and program no matter what skill set that they have. So let's talk about tonight. It's all about vision and control. What does that actually mean? What are we actually going to be going through tonight?
Yeah, so tonight we're going to be looking at sort of the fundamentals of writing vision code in LabVIEW. We're going to be looking at sort of the overview of what we use and the vision assistant, so you don't actually have to write vision code. We're also going to talk about PID control and how you implement that in LabVIEW and look at some of our simulation stuff, and we're actually going to be previewing our 2018 simulator. So this is something that only the beta teams have had access to, so hopefully you guys get a kick out of that too.
So you get kind of a first sneak peek at this if you're not a beta team, right?
Mm-hmm.
That's awesome. So during tonight's presentation, by the way, we are going to have some trivia questions scrolling either on the bottom if you're seeing this viewpoint or on the top of the screen if we're in the full screen mode. During those trivia questions as well, we have some sweet swag to give away from Annie Mark, and we thank them for that. So here's what you have to do, by the way, of course, with the RoboRio as well. If you're interested in winning any of our prizes tonight, just make sure you click that follow or subscribe button for a chance to win. And when the appropriate time comes up, if it's a trivia question, make sure you type in the correct answer into chat, and if it comes up for the RoboReel, we'll have a special keyword. So I mentioned this last show, but this is really the time, guys. If you're watching as a team, you need to get everybody in chat right now. You can have one stream up, that's fine, but get everybody in their own chat account and start spamming the correct answer when it comes up so you have a better chance to win, especially when that RoboReel comes. We want to see everybody get in chat and make sure you have an option for that. And by the way, if you do have questions during the stream as well, you can go ahead and tag at First Updates Now if you have a question about the any of the presentation today. If we don't get to your questions, we'll mention a little bit later, but we do have an area you can submit questions after the show that National Instruments can get back to you, right, April?
Mm-hmm. So I know some of these vision questions are a little bit more in depth, or you might think of something later, so this way hopefully we can cover as much as possible.
I actually expect you to answer all questions on the spot right away, personally.
I'll do my best, Tyler.
All right. So, all right, let's hop right into today. We're running right into time. We'll start trivia in just a little bit, and we'll get to that. But we got some cool live demos. We got some cool things to talk about with National Instruments. So let's hop right into our presentation today, April.
All right. Sounds good, Tyler. So like if you haven't figured it out yet, this is being put on by NI. And LabVIEW is actually used pretty widely across the world. It's used in high schools and colleges, universities around the world, from technical schools to PhD programs. So learning LabVIEW now can really give you a leg up on college applications and actually as you move forward into your career as an engineer. Looking at the LabVIEW continuum, sort of as it's seen in First, we are involved in everything from junior FLL through FRC, and then, like I said, continuing on into your university and your engineering career. There's a whole bunch of companies that use LabVIEW worldwide. You'll see some names on here that you recognize. all of these engineers sort of use LabVIEW in their day-to-day jobs, not just us who work at NI. So you'll definitely see it again in your career, so now's a great time to learn it. Speaking of one example of a company that uses LabVIEW pretty heavily is SpaceX. This is a picture of their early mission control room, and every screen in this room actually is running LabVIEW right now. So that's pretty cool. Another good reason to learn LabVIEW. Like I said, yeah, finding game elements or calculating distances for shooting or stuff like that. This is why vision makes your robot smarter. So that's why we put so much effort into learning how to do it. So let's go ahead and look at how would we implement vision code in LabVIEW. So looking at the next slide on opening vision code, if you want to edit your vision processing VI, this is where you'll find it. It'll be located underneath the target and underneath that team code folder. You can click on the little plus sign next to it to expand that folder down, and you'll see the vision processing VI there at the bottom. You can find it through robot main as well. It really kind of depends on which way you like to find it. But yeah, it should be the last VI in the default project folder because it starts with a V. Looking at the next slide, this is what that VI will look like by default. So there's a whole bunch sort of going on here, and so hopefully after this slide it won't be so scary. That first red box is all of the setup code. That's all the VIs it takes to actually open a connection to your USB camera, your IP camera, establish that connection, get images, set the right configuration settings, things like that. That's what's going on there. You don't really need to touch any of that. That should be good. That's just the camera setup code. That should be good. Inside this case statement on the right-hand side is really what you're interested in. You can see that we're in the true case here, and this is where you want to add your vision code. That first VI is actually pulling in the image data, and that's where you can add any vision processing code you want and get the image data out of that VI. So let's briefly take a look at the different vision VIs that we have in LabVIEW. If you do want to go sort of write your own LabVIEW code, your LabVIEW vision code by hand, they sort of fall into 6 categories here. So we're just going to go around in a circle. Starting with top left is image management. These are where your VIs to create images, copy them, get rid of them when you're done using them. They're all going to be located in here. This is more kind of like the management side of it. You want to find an image, open it up, close it. Intensity measurement is a really, really useful category of VIs. That's where you can actually read the pixel values and calculate the histogram for an image. It's a great way to find thresholds for different colors and values in an image. Similarly, particle analysis allows you to manipulate particles based on the characteristic of those particles and filter out ones you don't want. Display interaction lets you select a specific area of an image from an external display window. This can be really helpful when you're setting up your camera for the first time and you know that you only want, it happens to be the bottom left corner every time you try to approach the object. You can use that to select that area of an image, and then it'll be a lot faster processing moving forward. The image conversion VIs can either compare an image to a threshold or convert an image to an 8-bit or a binary file as well. It can be a lot faster for processing in those file types. And then the last category is image enhancement. This lets you equalize the colors in an image or make it all blue or something like that. So if you really want to go out, write your vision code by hand, this is what you would use. I highly recommend looking through the LabVIEW help for any of these VIs. These are all part of our actual industry standard, we call it IMAQ driver. So there's lots of non-FRC specific examples online if you're looking for more help. Google and LabVIEW help are going to be your friend using these VIs for sure. But let's say you don't actually want to program your own vision code because that sounds really hard and time consuming. We have this great thing called the NI Vision Assistant, and it will actually generate vision code for you, which is awesome. You can get to it by going Start, Programs, National Instruments, Vision, and Vision Assistant. You'll see the 2017 version if you open up from last year's code. This is from 2 years ago, obviously. Yeah, so this is the window you'll see when you first open it up. You'll want to click on NI RoboRio because that's obviously the target we're developing for. Unless you've gone out and found a compact Rio, you could do it for that too. But for FRC purposes, you're going to want to use the RoboRio. And this is kind of a rough example on the next slide of what you can do with Vision Assistant. You see we have these 3 expo markers here. Each one of these has a little box. That's because we've told it, hey, I want to find different color regions in this area of interest on the top here. And it says, okay, here's a blue square, here's a green square, here's a red square. So with Vision Assistant, you can walk through each step of your vision algorithm and tweak the settings along the way. You can either use a test image or pull a live image from your camera and then test your algorithm. It basically helps you to really quickly use guess and check to find the right functions, settings, and the order of these functions and settings to extract the data you need from the picture. So looking at the next slide, your typical vision processing algorithm is going to look something like this. You're going to want to first get an image and make sure it's an all right quality image, right? You can see here that this is from several years ago, I know. But you can see here that we can very clearly see those squares made out of retroreflective tape. This robot probably has a light on it. Highly recommend putting either that classic green ring of LEDs or a standard flashlight on your robot if you are doing vision. But once you have a good image to start with, you're going to want to go ahead and segment and simplify and convert it to a binary image where we're down to 1 color, right? Things we're interested in and black because we're not interested in anything else. Once we get that image, we want to clean it up because you can see we have these extra particles. We want to take that noise out, and then we want to actually extract the regions that we're interested in. So we're going to go ahead and do a demo of this. Tyler, I think that screen is up. If you want to switch over to that, probably see my face from a really nice angle. Hi guys. So now we're over here. So we're going to do a live demo of this. We'll see how it goes. But this is sort of the acquire images screen for NI Vision Assistant. You can see here I'm getting a live feed from a webcam. I have made this lovely example here that is definitely not a shape that will be used in next year's game. Do not be confused. This is the LabVIEW logo.
I think you just convinced everybody that that is a shape used in next year's game.
This is the LabVIEW logo. But yeah, so we're going to do this live. So we'll see how this works. These LEDs are very bright and I'm blind. All right, so we're going to have this over here. Should I do this with one hand? And if you can see on the left here, I'm actually toggling it to capture a still image. So that's now a still image of my LabVIEW logo made of retroreflective tape. And that's with this acquire still image button here. Now I want to take this image and use it as a test image to actually do my vision processing. So I'm going to select this far right-hand button where it says Store Acquired Image in Browser. When I click that, you'll see this left window up here updated to show my newly captured image. So great, I've now captured an image. I can close out of this Acquire Image and move on to Process Image. I'm not quite sure if it's cut off in the view you're seeing, but there's a button up here that says Process Images. We're going to click on that. So my screen has now updated to show all of my potential ways I can process this image, right? I'm going to get a chair because this laptop is shorter than me. Okay, so the first thing we want to do is isolate our LabVIEW logo, right? This is what we care about. So we're going to go ahead and extract a color plane to take our RGB image and make it something that's a little bit easier to work with. So I'm going to go ahead and pull out the blue plane, but I can click on these and sort of see which one looks best, right? That's definitely not what we want. That's really bad. This blue plane looks pretty good. My region of interest is showing up really bright and white and clear, so we're going to move on with that. When I've got this step configured the way I want it, I'm going to come down here and select this OK button. And when I do that, look in the white bar on the bottom of your screen. You'll see that this step shows up here. So I've now gone from the original image to this color plane extraction. Moving right along. So the next thing I want to do is actually go and take an image mask. I want to select the region of interest I'm interested in here. So all I've done is gone over to image, image mask, and you can see that this screen updates as I select the steps I'm interested in. So I'm going to come over here and draw my region of interest. That's what I care about, right? And I want to mask pixels that are outside the region of interest. Select OK. it's going to clean up my image a little bit for me. So once we've done that, we want to go ahead and set a threshold, which is going to be over here under grayscale, because our image is grayscale now, that pulls out only the bits of the image we care about. Whoops, that's not the right step. My bad, guys. That's the step I want. So you can see that it's turned a whole bunch of the pixels blue, right? We've told it that we want to look for bright objects, and we want to set this threshold manually. So I'm going to grab this slider and just sort of adjust until pretty much the images I want are selected. So if I go all the way too far, it's going to strip out too much of it, but that's a pretty good image, right? Now you can see here that I'm already getting some particles from the fluorescent lights behind me. Ideally, there won't be any fluorescent lights behind your image target. First try is pretty hard to put targets in reasonable locations, but we'll see if we can deal with that later. So I want to go ahead and hit OK, and you can see that it accepted my step. It's down here now. And now I have this. This is a much, much cleaner image than the original image we started with in the upper left-hand corner. So the next thing we're going to do is what's called morphology. Oops, it's mad at me. Basic morphology, sorry, because now my image has gone from being grayscale to binary. You'll get windows like this if you select something that the image type no longer supports. So it says, hey, this image is binary, but the gray morphology step only supports 8-bit, signed 16-bit, or unsigned 16-bit. So I just have to go find a function that works for my image. That would have been almost impossible for me to figure out if I was trying to do this by hand, so that's one of the great things about Vision Assistant. So I came over here to basic morphology. I want to get rid of objects, so I'm going to select erode objects. And then you can see that this window is the original, and this is the updated version. So I'm just going to kind of increase my erode objects until I get down to sort of what works. And you can see here that I was actually able to get rid of a lot of that light pollution going on here while maintaining the shape of the image I'm interested in. So that's cool. Once I've got that step set, again, I'm going to select OK. So now I pretty much have converted my original image into this very nice, clean, binary image. The last thing that I want to do is run this particle analysis. And you can see here that it's going to return 3 results. And if I click on Show Labels, it will show me what it has labeled each of these particles. And each particle is going to be one contiguous region of color. So you can see that our triangle here is particle 1, our plus sign is particle 2, and this little dot I wasn't able to get rid of is particle 3, which makes me sad, but it's there. The interesting thing about particle analysis is that if you look down here in this white bar, it returns information about it. So it says, hey, the center of mass for this shape here is at these coordinates, x and y. Same for this one, and same for this unfortunate little particle we still have. But we can only look at these two. And we say, hey, the first pixel, so this very top left corner is here. And we get all this information back from it. This is the information that we actually care about. This is what we want to use in our vision code. We want to say, okay, great. I know that my triangle has the center of mass here. That's where I want to point my camera, and that's where I want to point my shooter, and that's where I want to launch a ball, right? So once we run our particle analysis, this is always going to be the last step because this is what's going to return the information you're interested in. Great. So we have our vision algorithm. That's it. That's the whole thing. But this isn't very helpful, right? This doesn't look like useful LabVIEW code because it's not yet. The last thing we have to do is actually extract the code. So we come up here. Clearly, I know what I'm doing. So we're here under Tools, and we want to go to Create LabVIEW VI. This is what we want to use. Don't select Create LabVIEW FPGA code. You won't be able to use it. You can't put it on the FPGA on the RoboRio, so you want to create a LabVIEW VI. When we select this, it's going to say, hey, pick your version of LabVIEW because I have 2 versions installed on here. You want to pick the newest version for that year. So you can see that I'm still running last year's code, but LabVIEW 2017, or actually no, I'm sorry, I'm in beta code now. LabVIEW 2017 and NI Vision 2017. So then I have to go pick a file path. I want to save this somewhere I can find it later, which for me right now is the desktop. So we're going to save this as Vision Algorithm 1. And then if I select Next, I want to use the current script because that's what's actually on my screen. Otherwise, you can save these little Vision Assistant scripts, and you can go pick them later if you want to export it then. Click on Next. Yeah, so you can pick either of these, an image control or an image file. It's not going to matter because when we go to port this into LabVIEW, we're going to get rid of that code anyways because we are acquiring the images live from a camera. Hit Next. Now this screen is where you can pick and choose what indicators and controls you want available once you get this into LabVIEW. So for example, if I wanted to, I don't know, be able to toggle, like if I wanted to pick stuff inside the region of interest or outside the region of interest, or select what structural element I used in the Morphology VI, I can toggle these controls and indicators on and off. The one thing you do want to make sure you include is the particle statistics. That's what actually gets you that information we talked about at the end. That's the useful stuff. So make sure you put that in there. Everything else is sort of as you please. Select Finish. It's going to do some thinking. And it's going to be generating the LabVIEW VI in the background. Probably see some nice black boxes on my screen right now because I'm not sharing the LabVIEW VI. Let me see if I can sort that out right quick. That's about what I expected. Okay. See LabVIEW? Awesome. So this is what it created for me, this VI. This is called Vision Algorithm 1 because that's what I called it. I'm going to press Control E and open up the block diagram. And you can see here that it brought in all the stuff I told it to. It spaces it out very nicely for you. So you'll probably want to compact that when you go to bring this into LabVIEW. This code over here is the open from file code that we told it to make because we told it we wanted to make an image from a file. That's going to go away when you actually bring this into LabVIEW. This wire, you'll be able to connect it to the Vision VI. And then you'll see that all of our settings are in here, our ROI, our thresholding, our center of mass. All of this is in here. It's already done for us. We just have to stick it into LabVIEW and then use the data that it returns. Yeah, so our particle data is going to be in there. And that's it. That's Vision Assistant. So I think we can go ahead and go back to the PowerPoint now.
All right, we can do that.
See if I get back on this camera.
So we do want to start the trivia in just a little bit, April, and we did have a couple questions I want to grab from you right away too, if that works. So do you want to start trivia first, and we'll grab a couple questions?
Sure, we can do the first trivia question, and then we'll do a couple questions, and we'll go from there.
Let's see if I can get it up here. All right. You can ask if you want. Go ahead.
Sure. So the first trivia question for today is, what is the name of the program used to generate LabVIEW Vision code?
All right. So
2 words.
Yep. So what is the name of the program used to generate LabVIEW Vision code? So you can go ahead and start spamming them in the chat if you like. Make sure you do have to follow or subscribe in order to win. If you're not follow or subscribed and we draw your name, then it's going to redraw. And it's 2 words, no exclamation points or anything like that, all guys. So 2 words. Make sure you spell it correctly. It is not case sensitive. So start spamming that. There might be a correct answer too. I'm not quite sure. So we'll see. Questions I wanted to ask you, one in specifically about what you just went over. So J. Roth Ritchie asked, can you do this first capture process with the camera plugged into the computer as opposed to the Rio?
Yeah, that camera was plugged into my laptop. I'm not even running it on a Robo Rio right now because that would have been a lot more complicated to sort out with Skype. So yeah, that's just plugged into my laptop, which is the nice thing about Vision Assistant is you as the programming team can be working on this while hardware has your RoboRio, for example. And then when you get a RoboRio, that should be the same. Nothing should change in that vision code because it's going to process in LabVIEW the same way.
Sure.
Now, obviously, you'll probably need to do some adjustments when you get to your competition, for example, because the lighting in that gym or that arena is going to be totally different than the lighting in your shop. So be prepared for that, but otherwise it should transfer pretty much the same.
All right, we're going to draw for that trivia in just a moment here. One other question, more of a general question. Mm-hmm. Maybe this is something in a further session we might get to, but I'm going to butcher this name, so I apologize. TIJIHBA asked, will the tutorial cover, or will a future tutorial cover, how to make the robot move using coordinates that we get from the camera? For example, rotating the robot so it aligns with the goal.
Yeah, so we don't cover that tonight in the interest of not being here till midnight. Because I know it gets kind of late for you East Coasters out there. But yeah, we have a couple tutorials on na.com/FRC that can be put together to do this. Otherwise, I know there are FRC teams out there who have really detailed examples of code from previous years, and those are some of the best sources to use.
Excellent. Oh, I always forget to mention the prize. I'm so sorry. So our first prize, I got to bring it up here. I think, what are we doing the first? I think we got another
steampunk shirt.
It is another steampunk shirt. That's right. So yeah, steampunk shirt, courtesy of Andymark. So you can go to andymark.com and check out their steampunk shirt. That's what we're going to be giving away. So let's go ahead and do that giveaway right now. Actually, we can continue the presentation, and then we do have 3 trivia questions tonight, guys, total, and then of course the big RoboRio giveaway. So with that said, our winner is Logic Bomb 50. Logic Bomb 50, congratulations. Yay, you have won the giveaway. Please shoot me a DM on Twitch or a PM on Facebook or in our Discord with your information. And congratulations. Once again, Logic Bomb 50 wins the giveaway. Congrats there. All right, and we got, 2 more trivia questions later, right, April?
Mm-hmm. Yep, we got 2 more coming.
All right, let's get back to our presentation.
Cool. So you can probably go ahead and skip forward a few slides. This whole demo that I went through was actually gone through slide by slide in this PowerPoint. It'll be posted on ni.com/FRC after, I believe it goes up tomorrow. So you guys will have this to refer back to as well. But if you want to get to the slide that says integrate vision code.
Integrate vision code. See how far I have to go. I probably went way too far already.
If you went past the question slide, you're too far.
Oh, I went past. There's vision questions, right?
Yeah, go back 3 more slides.
Integrate vision code.
Yeah.
I did it.
So,
all right. Excellent.
Good job. So this is where we get sort of where I left off. I would have copied that code out of my vision algorithm VI and pasted it in here. You can see that this purple image wire comes right out of the open image and goes right into those iMac VIs. So that should be fairly seamless for you guys to copy and paste over. All your vision code should sort of go in this case statement, and you should be able to move on. Now, one thing I do recommend is if you go to the next slide, you typically probably want to convert that into a SubVI because it makes it a lot cleaner. This code is a lot less scary to look at than the code on the previous slide. So I highly recommend selecting all of your code, right-click or edit and create SubVI. It'll compact it down into a SubVI for you. We went over that in the previous tutorial, or in the previous webinar, and there's a tutorial on ni.com/FRC as well. If you want some vision examples, looking at the next slide, I should say 2018, we will have a 2018 game-specific vision example. It'll be built into the examples in LabVIEW, so you'll have that to look forward to. I know nothing about it, don't ask. But we'll have that as well as the rest of our normal vision examples. Any other vision questions, looking at that question slide, or we can move on. We do have, like Tyler said, we'll have a link up. I believe he converted it into a bit.ly. That's just a Google form. You can type your questions in there. I will take a look at those. Anything we don't get to in the course of the show, I will answer afterwards and post it in a post on the blog on ni.com/FRC. So we do want to get you guys those answers. We just also understand that some of the vision questions are in-depth or long or specific.
Yeah, we'll put that link up near the end of the show as well.
Cool. Awesome. Well, we can go ahead and move on from vision then and start looking at control. Specifically, I want to talk a little bit about open loop versus closed loop control, because this is sort of what most control algorithms are built on. So open loop and closed loop is really just this. Open loop control is just do something. This is pretty much what every single FRC team uses when you're doing your drivetrain or your drive motors, for example. Joystick moves, do that. Your robot doesn't care what's in front of it. Versus closed loop control, which is do something and check a response. So you're going to get some feedback is going to be involved in that loop in order to continue to do something or do something else. So let's look at a really basic example. Looking at the next slide on open loop control. Imagine if you were filling a glass of water without looking. Seems fine, right? You don't have to look. You know how to pour a glass of water. What if you don't know what was in the glass before you started pouring? What if it's already 90% full of water and then you try to pour 3 more seconds of water into it? You're going to end up with water all over your table, which would be unfortunate. Same as if the bottle is full of water and you don't know how much water is in the bottle, that's going to pour differently than if you're almost out of water. These different sort of conditions around a decision is what sort of defines open loop control. You just want it to do something and you sort of have to cross your fingers and hope that it works out. So like you can see in our code at the bottom of the slide, we're pouring out the water bottle. We're going to pour for 3.5 seconds and then we're going to stop pouring and hope for the best. Maybe there's some water in the cup, maybe there's water all over the floor. We don't really know. The beauty of closed loop control, looking at the next slide, is that you get to have some insight into what you're doing. You get to look at that glass as you fill it. So you're pouring the water out, you're checking to see if the glass is full, and then you can decide if you want to keep pouring or stop pouring the water. That's what closed loop control is. You get to mitigate all these potential sources of error. It's a really, really powerful idea, sort of the difference between closed loop and open loop control, that gets implemented a ton in robotics. So kind of like a smart person will always look at the glass they're filling to make sure they fill it all the way up without going over, a smart programmer will try to use closed loop control to make your programs more reliable in different conditions, is really what it gives you. So looking at one of the most common sources of closed loop control is PID. It's one of the methods of closed loop control. It's the most common method of closed loop control. It stands for PID is proportional integral derivative. And it's basically just an algorithm that's used in a control feedback loop to regulate a process such as the motion of a motor or the rate of flow through a valve, things like that. In order to use PID, you have to be able to monitor the output. So for example, things that help with PID, encoders, for example. You want to know how far that wheel has turned. That encoder can give you that feedback that you need to implement closed loop control. So looking at the next slide, we have an example of like PID in the real world. Consider having this giant cannon gun on a battleship and you want to rotate it 90 degrees. If you turn the rotation motor all the way up and then stop it suddenly, your cannon's going to shake really violently when you stop it, which is sort of that black line that you see there. Ideally, that blue line is what we want, right? That's our end goal. We want to go from 0 to 90. The black line is way too much like shakiness, way too much of an aggressive response. If you see that red line, it's smooth, it gets there, but it takes a really long time. That means we've turned the motors to 10% and we just sort of watch it go until it gets there. That green line in the middle is sort of our happy place, and that's where we can get with PID control. That gives us the opportunity to overshoot a little, but compensate and bring it back to a smooth, steady arrival. So looking at tuning a PID controller. PID has to be individually tuned for every individual system. That's what makes it powerful, is that it's customizable, but it also means you have to do it. You're going to want to adjust those PID gains, and we'll talk more about that in just a second, to appropriate values for your specific system, because you want to decrease the rise time, which is how long it takes to go from the initial state to the final state, and reduce the steady state error without having too big of a percent overshoot. It's sort of a balancing game. You want to kind of mitigate all of these things to have the least possible offset in all areas while still getting to your end goal. So I'm going to talk about control values. And then we'll do a trivia question because I know this got really boring really fast after vision. So we're going to keep it exciting. But so looking at PID control variables, this is what they're called in LabVIEW. You have the proportional gain, which is represented by the variable Kc. Kc is the what we call the primary gain. You're going to want to, when you're developing your system, you're going to want to increase Kc until your signal starts to oscillate. And that's sort of what we were seeing in those graphs earlier, how it was going around that top line and then slowly settling out. You need to reach that oscillation before you can dampen it out. Once you reach that point of oscillation, that's your critical gain. That's the Kc value. The integral time is represented by the variable Ti. You're going to want to set this to 0 when you start determining Kc. Both integral time and derivative time, which is Td, these need to be zeroed out before you start to find your Kc because they're going to have an effect on the system. Yeah, pretty much that. You can see in sort of that box on the right-hand side, that's what a PID gain set looks like in LabVIEW. And that's a pretty typical set values too. Proportional gain of 1, an integral time of 0.01, and a derivative time of 0. Your Ti and Td are going to be a lot smaller than your proportional gain. Do we want to do that trivia question? Are we too close to the previous one?
I don't think it's ever too close, especially if you ask chat. I don't think they're going to mind at all. So.
All right. Well, we can go ahead and do a trivia question. So our next trivia question is, what type of control depends on feedback from some kind of sensor?
It's 2 words, by the way, right?
Yeah, 2 words.
All right, and since I always forget, by the way, I'm going to say the so the winner of this is going to receive a 1/2 inch hex blue 4-inch compliant wheels, courtesy of Annie Mark. So once again, you do have to make sure you are either following or subbed in order to win. Go ahead and start typing that answer in as much as you like. And we do have. Can we take a couple Q&As here, April?
Yeah, if we have a couple questions, we're going to talk a little bit more about how to specifically tune this here in a second.
Okay.
But if there are any questions over other stuff.
Yeah, I'll read a couple. I don't know how specific this is going to get, so we'll see. Question from SA Taylor 000 says, one of our problems our team and quite a few others that person has talked to is interference from other light sources, for example, fluorescence. That are either beyond the target or reflected off the polycarb panels. Filtering these has turned out to be quite difficult in the arena, and the size is often distressingly similar to actual targets. Any tricks you can recommend in Vision Assistant to work around this?
One of the best things you can do is, again, just play with that algorithm as much as possible. If you know you have these issues when you go to competition, try to simulate them at home. Take an LED source and shine it at the polycarb that you're trying to read your values off of. Is it possible to isolate that out? Can you sort of replicate the system at home so that you have as much time as possible to practice with it before you get to competition? That's definitely a known issue that every team deals with. It's hard. That's one of the ways first is very much like an actual engineering environment. Everything's not going to be perfect all the time. You're never going to have this ideal environment that everything works perfectly in. Sometimes people will take our industry devices like our C-RIOs and stick them in a buoy on the ocean, and suddenly it's just going through a hurricane and you have to sort of hope that it still works. So trying to make your system as robust as possible to prevent against that is really done preventatively by testing. And as similar as you can get that testing environment, the better.
Awesome. Let's answer one more question, then we're going to do the drawing for that. So once again, make sure you do follow or subscribe. Question from Terra Nova R1 said, when being taught by my programming mentor who works for a corporation, he said that you should only really use P and I gains to get what you need. D is too small to do any real good, so don't use it really. Would this be something that you recommend?
Sure. That's very solid industry standard advice, especially in bigger systems. The smaller your system gets, the more relevant using all 3 of these variables to their fullest extent becomes. But this is the real world. This is a robot. You're going to have sources of error that we can't compensate for. Maybe there's a bolt loose on one of your wheels. Maybe that little roll of the mechanisms as you stop changes things. So using Proportional gain and integral time is really what you're going to want to stick to. Those are going to have the biggest effects on your system. You can sit there and play with 0.01 of a TD for hours and see no change. So that's very good advice. Thank you to whoever said that.
Awesome. So let's go ahead and roll for the winner of this trivia. So you're going to get the AndyMark compliant wheels sent to you. And the winner for that is FRC4292. Congratulations. Go ahead and make sure you shoot me a PM here on Twitch or in our Discord or on Facebook with your shipping information so we can get those mailed out to you. Congratulations, and thanks for following as well.
Right. Cool. So we're going to go back to, if you want to jump down to the next slide, look at tuning PID values. There's really a couple different schools of thought around tuning PID values. You can do it through trial and error. This is really easy to do in simulation. This is kind of the easiest way to do it, honestly. If you have a system you can play with, this is the easiest way to do it. You're going to get the best results out of this as well. It might take a little bit of time to get right just because you do have to iterate and iterate and iterate. Another really common method is known as the Ziegler-Nichols method. And you can see this lovely table that I pulled from Wikipedia on this. Again, PID is not something that's specific to LabVIEW per se. It's something we implement very well. But if you want to know more about it, give it a Google. There's a ton of information out there. But basically, the Ziegler-Nichols method, you want to go ahead and determine that Kc, in this table it was called Ku, that critical gain. From there, you can go through and calculate the different starting points. The one thing to keep in mind is that even when you're doing manual calculations to figure out your starting points, you're likely going to have to do some tweaking afterwards to account for the actual system you're building on. So going on to the next slide, PID in LabVIEW. The LabVIEW for FRC PID palette consists of 4 different VIs. We have the PID.VI, which is really the only VI you're ever going to use, the set point profile, the control input filter, and the lead lag. Those last 3 definitely are a little bit more advanced. You have to have a little bit better of a grasp of PID in general to use them effectively, but the help documentation for them are really fleshed out. So if you want to get into that, if this is something that's really interesting to you, take a read. Feel free to hit us up with questions on the forum and we'd be happy to answer them. But if you go to the next slide, this is a screen cap from our general PID simulator example. It's in our example finder. This is where you can go to sort of play with PID and see how things are affected by the changes you make. So you can see that we set some coefficients on the front panel, and we use a shift register on the, you can see that on the far right and the left-hand sides to pass that data around from loop to loop. Those are really critical in PID because we need that feedback to actually create effective control. Otherwise, we've basically created a really, really fancy open loop system. So looking at the next slide, this is the front panel for that PID simulator. You can see that we have the graphs showing the response, showing the set points. It's really fun to play around with. It's a great way to get a little bit more familiar with PID. And I would highly suggest checking it out if that's something you're interested in learning more about. And sort of the last note on PID is that even closed loop control isn't perfect. Encoders can't detect if a wheel slips on the floor because they just measure how far the wheel rotates. Mechanism wheels are even harder to measure the distance. Things don't work perfectly. Your line sensor might not trigger. Things like that, like whomever commented earlier mentioned, light levels change in different lighting scenarios. Ultrasonic sensors can give bad readings. The key to good, especially auto-on closed loop control, is lots and lots of testing in as many different situations as you can get your robot into. Even if that's sort of manually creating some of those bad situations at home is a really good way to establish a more robust control loop system. Cool. So we can move on from closed loop control, PID, unless there are any last minute questions. And again, we'll have that question form up if you guys do have questions at the end. Cool. So back to exciting stuff. We made it through the math, guys. We did it. I promise, no more math. I want to show you the simulator that we have for next year. So we have this robotic simulator built into LabVIEW. This is a really, really powerful tool that I think is really underutilized by a lot of teams. You can see here that this is the view it gives you once you run the simulator. We'll talk about how to get into it in a second. But you're able to speed up or slow down the simulation. You can run this at 10 times speed, which is really fun to watch your robot zip around. You can change the views. You can zoom in and zoom out, things like that. This particular example we'll talk more about in a second.
This kind of looks like a Pac-Man game, by the way. This isn't a hint for next year or anything, is it? I mean,
No,
kind of a,
this is not a hint.
there's kind of steps and stairs and that sort of thing.
Oh yeah,
Just saying.
totally, definitely a hint for next year. Wink, wink. No, it's not a hint. I
Somebody
promise.
clip that, please. All right.
No, please, no hype trains. Not a hint for next year, but hopefully helpful for you guys. So let's look at the next slide and how do we get our code into simulation mode. When you open up Robot Main, you're going to want to go ahead and open up the driver station as well. You need it for real and simulated robots. But when you open up Robot Main, you can right-click in that lower left-hand corner. You can see that there's that little drop-down. It's going to say 2017-2018 Robot Project.lvproj/target. That means it's pointing at your RoboRio, which is what you want when you're trying to put code on the RoboRio. But when you want to run the simulator, you want to right-click on that and select 2017 Robot Project/My Computer. This tells it to run on your local machine rather than try to deploy the RoboRio. When you click that, it's probably going to pause for a second and load a whole bunch of VIs, and the simulation viewer will open. When you click Run Robot Main. So you're going to just click that white run arrow in the top left-hand corner and go from there. This will all deploy. I'll pop over to my other computer and show you here in a second. Yeah, so let's go ahead. We'll go through the demo in 1 second. If you skip past that next slide to deploy to the real FRC robot, this is really, really important. Once you put it into simulation mode, if you want to put the code back on your actual RoboRio, you have to toggle this back to /target. Otherwise, you'll continue to deploy to your simulated robot and your code on your RoboRio will never update. You'll be really sad if you made some cool changes and you wanted to test them on the real robot. So, can we switch back to the other simulation? It's probably still on my vision code. Get out of that. Cool. Awesome. So this is sort of what it looks like when you run the simulation. My robot main is over here. This is so let me talk about this example real quick. We built this dashboard maze example. This is really intended for learning LabVIEW for FRC. We struggled a lot in the past with our simulator because we were trying to be something we're not. LabVIEW is not a simulation language. We are not CAD. We're not meant to do that, but we're really, really good at implementing code. So what we basically did is gave you a basic robot. It's got 4 mechanism wheels and a camera on it. That's it. And when you run this, you're able to add programming to your robot and actually program for all of the sensors that are on it. If you look in and you guys don't have any of this code, this is new for 2018 for next year, so get excited. You'll get this at kickoff. It's really cool. But in here, there's a readme.html. It tells you what sensors are connected to what ports on your RoboRio. And you can use that to write Auton code to help this robot navigate through the maze, ideally autonomously, because you'll be able to see what color the walls are. You'll see that all the horizontal walls are blue, all the, vertical walls are red, in reference to the robot. There you go. Now the walls are the direction I told you they were. You can use those color sensors. You can use the encoders on it to see how far it's gone. And you can navigate through this maze autonomously. I believe it can be done. It'd be really cool to see you guys do it. Anyways, how to get this into simulation mode. You can see here that I've already toggled it over. I've selected my computer. If I wanted to deploy this to a real robot, I would select /target, but I don't. So I'm going to go ahead and run this for you real quick. We'll turn on vision. No, we don't need vision. You can toggle vision. It has a camera on it, but the update rate is going to be really slow over Twitch, so we're not going to do that. So when I run it, you see that this sort of jumped, and this is running now. So I can grab my controller, which is somewhere. You can see my driver station is down here, I still have to come down here and enable it. This is just like a real robot. So now you can see that I have it enabled. If I go to the side view, back to driver, you can see, hopefully, there's my little robot. And I'm just sitting here with a joystick doing a really bad job driving. But it's designed to fit perfectly in this maze so that you can sort of only move in lateral directions and actually navigate successfully through the maze. Yeah, the end goal is that you do this autonomously. But this is one of our 2 new examples. We'll have another one that involves shooting balls for next year. Those will be rolling out with LabVIEW LabVIEW for FRC 2018 at kickoff. But that's sort of the simulation in a nutshell. We do have some pretty good tutorials on this on ni.com/FRC. And this is going to be all new for next year. So I'm really excited about that. I'm really excited to see what you guys can do with that because you guys are actually incredible programmers. So we can probably switch off my simulation, which just got real dark in here. They turned the lights off on me. But so we can come back over here. Cool. So yeah, don't forget to toggle it back. That's really important. Looking at the next slide, these are some of our simulation vision resources. If you still want to configure that access camera, we still support that. Teams still use them. How to use targets, PID theory, robot simulator tutorial. That'll be updated at kickoff as well for all the new stuff. And then yeah, forum support year-round, ni.com/FRC. I'm on there. The engineers who develop LabVIEW for FRC are on there. The engineers who build the RoboRio are on there. So it's a great place to get help if you're a LabVIEW team, if you have RoboRio questions, things like that. And yeah, during build season, feel free to give us a call, 866-511-6285, from 1 to 7 p.m. Central Standard Time. We are in Austin, Texas, so you're stuck with Central Standard. But yeah. Awesome. Real quick, the second part being 10 more slides. The second part of this presentation kind of goes over more advanced programming. So we're going to look briefly at dashboard customization and then look at some of the helpful debugging tools that we have. If you want to build a custom dashboard, the default dashboard opens up when you open the driver station, but you can build a custom dashboard in LabVIEW as well. You go into this dashboard project. It's going to be right there on the splash screen when you open up LabVIEW. If you go to the next slide, you can add additional robot controls and indicators. You can add a target color if you want to be able to change that on the fly. Anything you need to adjust from your driver station can be added to this PC dashboard. Looking at the next slide, one thing that's pretty critical to do when you're building a dashboard is connect your custom variables back to it. And the way we do this are through our network table VIs. These are going to be all the VIs that have the little yellow NT in the corner. They're under the network tables palette. And when you save something to these VIs, they're going to be automatically put into a repository that your dashboard has access to. So you can just go to your dashboard, program something using those variables, and it will find them for you.
Hey, April, I want to just go back a second here, by the way, to the dashboard that's up. So this is what the 2018 dashboard is going to look like then?
Oh, 100%. 100%. These robots were built for 2018. This is...
Oh, not the robots, but the dashboard itself, I'm asking.
Oh, no, not at all. This is from like 2011.
All right, I just want to make sure.
This is very old.
Not all of our people are from 2011, and I wouldn't remember that anyway, so never know.
So, but yeah, no, this is very old. It's just an example of some custom controls you can add. The dashboard will look very similar to how it has the last few years.
Very cool.
If you go to connecting custom variables to the dashboard, slide 2, you can see that we're on the custom tab of the dashboard. So this is where you'll want to pretty typically put any of your custom variables. This is a great place to put them. We've sort of left space in the dashboard for them to go here, so you don't have to worry about reconfiguring everything that's on there. And you can see here that all I've done is said, hey, I want to write this Boolean to a network table. I've called it move arm. And you can see that I called my Boolean and dashboard main move arm as well. As long as those two strings match, that will automatically go to that Boolean. That's all the configuration you have to do to make that happen, which I think is pretty quick and easy. So looking into a little bit more on what is in the dashboard, you can record and play back your matches, actually. It's not used super often, but it's there if you want it. It's going to be in that lower right-hand corner, playback, record, and stop. Just make sure you toggle record before your match starts. Definitely don't do it while you're not supposed to touch the dashboard during autonomous, but start your recording there. If you go to the next slide, that's where it's going to save these logs to. Users, public documents, FRC log files, and then in a dashboard folder, it'll get this nice red border that you can see on this slide when it's actively recording. And if you go to the next slide, when you're playing something back, it'll have a green border. You can just, if you want to select a recording to play back, you can just click on that green triangle. You'll have to select a log file and you can move on from there. This can be a great way to kind of see what went wrong in a match or something like that.
So there's ramps in the game?
Oh yeah, definitely. Definitely ramps.
Right.
This doesn't look very familiar to 2011 still. So we used to update our simulator to try to reflect the game every year, which worked really well up and through Recycle Rush. And then Stronghold happened and things got really complicated. So we stopped and decided to optimize it more for a learning platform rather than a build your robot in LabVIEW, which isn't really CAD, but we kind of pretended to be for a while. So I want to talk briefly about troubleshooting and how do we troubleshoot? Yeah, we're almost there. 2 more slides and then we'll do the trivia question. Sneak hint. But troubleshooting can be really, really effective when done from the driver's station. We have all of these really helpful charts built into it that can show you any network issues. So like lost data packets, what your trip time is, your battery voltage, your CPU usage, how much like CPU and RAM is free on the RoboRio. All of these things are documented during your match. So if your FTA says, hey, you were using a lot of bandwidth, you can go here and say, oh yeah, I was using a lot of bandwidth. Let me turn the resolution on my camera down. Things like that can be really easily identified through the driver station. And looking at the next slide, looking at troubleshooting event error logs, you can click on this little gear to open up the log viewer, and that opens up this window on the bottom. This will have, if you've used a laptop at a competition, so many logs in it, so you can find the ones that were from your matches and get all this information. Every time it disconnects, it says, hey, this is what I lost first. I lost the RoboRio first. I lost the radio. I powered down. All of this information comes back to the driver station and gets stored in these logs. This is one of the most useful things I found as a CSA to help teams figure out what went wrong. So hopefully more teams can start using this on their own. And if they have any questions, again, feel free to ask us. Grab your friendly CSA at events, things like that. These error logs are also stored, if you go to the next slide, at users, public documents, FRC log files. They have both those graphs, and then here we're showing the event list. So this lists any important event that might have occurred during your match. Things you really want to be aware of are going to be in this list. Do we want to go ahead and do that third trivia question?
Yeah, let's go ahead and do it. I'm totally down for it. So let me make sure I got Nightbot up. Yeah, go ahead with it.
All right, cool. What icon do you click on in the driver station to view the driver station logs?
So what icon do you click on in the driver station to view the driver station logs? All right, go ahead and type that in and make sure you are
One word.
It's one word. Make sure you're either following or subscribing. And speaking of which, I always forget the giveaway. So we're going to be giving away another steampunk t-shirt from AndyMark once again. So go ahead and check them out at andymark.com. Get a chance for a steampunk t-shirt and start spamming the answer into chat. We'll be giving that away in just a little bit. Did you want to take a couple more questions, or do you want to wait for the RoboRio giveaway?
If there are a couple questions, we can go ahead and take those now. Otherwise, I have 6 slides till the RoboRio giveaway, so
okay.
Whatever we want to do.
That's coming up, guys. This is the time to start getting people in chat, by the way. Start hitting them up and get them to sign in the chat. Mm-hmm. So SA Taylor 000 asked, how does a simulator handle other real-time inputs like encoders or switches?
So those are actually, that simulator I was showing you is built into that robot. So it handles them in real time. We've told it, hey, you have an encoder on all your wheels. It's going to go ahead, and act like it has an actual encoder, you're going to get real feedback as if that were a real robot. That includes if that robot slides because you went really fast and then slid into a wall, your encoders are going to be off because of that. It does have gravity, it does have physics, so it's as kind of close to a real-world simulation as we can get. But there are sensors built into that robot, and those are all documented in the help files for that example.
Very cool. All right, Terranova R1 asked, when I'm going to read verbatim, when I've made dashboards in the past, the booleans don't grow bigger when I build it to where it needs to go. Is there a way to make them grow with the screen?
Okay, I think I know what you're asking. This was a bug a couple years ago. I think we've sorted that out. If you're still seeing that problem, please post your code on ni.com/FRC. We'd be happy to take a look at it. We're always looking for ways to make our stuff better. We're obviously not perfect. We never said we were, but we do try to do our best and do our best by you guys. So if you're still having problems, definitely let us know. As far as I know, that's been fixed. Would be interested in hearing if it wasn't.
Yeah. By the way, that's a really cool thing about NI guys is that they're very, very open and very willing to answer your questions to make sure they get it right. Right. I mean, you guys. I mean, I don't want to speak for NI because I don't work for NI, but you guys, at least the experience that I've had with you guys is that you're really on top of things. You're there to make sure the teams are benefiting from your program, but also making sure, on the other hand, that you have a great relationship with them as well, so they can make great robots too. Right.
Yeah, absolutely. Pretty much everyone I know who's involved with FIRST at NI is also involved with FIRST outside of NI. They either mentor a team or they volunteer. It's a program a lot of us care a lot about, and we want to see you guys be successful. And the last thing we want is something we're doing wrong to hold you guys back. So the sooner you can tell us, the sooner we can do our best to fix it. Like I said earlier, we really want to do right by you guys. We care. I promise. We don't bite.
I promise.
We're a little sarcastic, but we don't bite.
There you go. Excellent. All right, let's go ahead and do the giveaway for that. Of course, the correct answer was gear, by the way, right? We didn't. I don't think we said it for the other ones, but correct answer was gear. So the winner for that is going to be a new follower today, METEUSRAEL. I'm gonna just spell it that way and not butcher it. So go ahead and shoot me a message. Congratulations to you for winning. That's. Once again, you get a steampunk t-shirt courtesy of Andy Mark. So thank you, Andy Mark, for giving those out as well. And guys, the Robo Reel giveaway, we got a few more slides to go through. The Robo Reel giveaway is going to be next. We're getting there, guys. We're getting there.
Cool. So moving on, I want to talk really briefly about some debugging stuff, some troubleshooting stuff that we have, particularly breakpoints. These exist in LabVIEW like they do in any other software programming language. You can right-click on a VI, you can right-click on a wire, you can see some examples of a breakpoint on a SubVI or a breakpoint on a wire. To add a breakpoint, it'll be in a drop-down menu you see there, right-click breakpoint, set breakpoint. The breakpoint manager that you see in that drop-down will actually list all of your breakpoints, and you can double-click on them and it'll take you to those breakpoints or show you what those values are, so that's really helpful. But this can be really, really helpful in debugging logic execution. I don't recommend putting these in robot code that you're trying to run on the RoboRio because you will slow down all of the communication and it will enter its like safe state, and then your test will sort of be defunct. But really useful in debugging logic, state machines, things like that. You can single step through stuff just like you would any other programming language. You can probe wires to check intermediate values, change the values of front panel controls, and see how your code reacts. So it can be really, really helpful. Performance? Cool. So the other thing we have is this performance profiler. It's under Tools, Profile, Performance and Memory. This can be helpful in determining how fast a single VI runs. If you want to know how fast your SubVI runs, because it matters if it's 10 milliseconds or 10.5 milliseconds, this is the tool you want to use to figure that out. But yeah, it lists all these different timing statistics, like the number of runs, how many times was this VI called, what was the average amount of time it took, what was the shortest, the longest. This can be really helpful in seeing how things change the more you run them. Or if certain sensors return really slowly, this will sort of reveal those things to you. It also says, gives you back your memory usage. So like your average bytes, min, max, things like that. Again, helpful if you have really intense vision processing code and you want to see how many bytes that's using. Really briefly on the watchdog, your system watchdog lives on the FPGA and it monitors the communication from the driver station. Basically, it's there to turn off the outputs if there isn't any robot communication in 100 milliseconds. Typical causes of that turnoff is if there's no communication, if there's a slow communication, if you're overloading your CPU, or if your driver station is running too slowly. If you have an older laptop and Windows is trying to update the same time you're trying to run your driver station for your robot, you're gonna have problems. We see it all the time at events. It happens. But things like that will interrupt that communication chain, and this watchdog is just here to keep everyone safe, keep people safe, keep robots safe. So just be aware that it's there. And if you start seeing these kind of interruptions, these are some causes of them. So looking at safety configuration timeouts, you can enable or disable safety timeouts. We give you that ability. They're available for robot drive, motor control, PWM relay, and solenoid control as well. And it's going to be this safety config. This is sort of an alternative to a user watchdog. I highly recommend leaving these enabled. The neat thing about these is they're output specific. So you can turn them on or off, enable or disable them for individual outputs. So if you know, for example, that you have a really, really slow updating motor, you can toggle this off and save yourself some bandwidth there. So only the enabled outputs that don't update in time are going to be caught by that watchdog. Now don't go set all of your drivetrains to disabled. Don't do that. It's here for safety. Like, we want to keep you guys safe. We want you to go home with all your fingers and toes. So definitely enable them for your like mission critical motors, but it gives you that option to choose. Really briefly on autonomous strategies. This is the easiest autonomous. This is what comes default in LabVIEW. If you run autonomous, this is what it's going to do. It's going to turn one way for a second and the other way for half a second and then stand still. This was put in there to give you a base to build off of. There's typically some kind of autonomous that's just drive forward and cross a line. It's been in the last couple games because we, again, first wants you guys to succeed and feel like you can do things. This kind of code will get you those autonomous points. So one of the things to remember about autonomous is that it doesn't have to be complicated, it doesn't have to be fancy, it just has to get the job done. This would be an example of open loop control, sort of bringing back in what we talked about earlier. There's no response from this. Your robot's going to go and execute this, whether it's running into a wall or whether it's running into another robot, or it's not actually moving and your motors are unplugged. It's still going to run this code. So looking at sort of a closed loop feedback idea for autonomous strategy, you can implement sensors. Here we have like an example of an ultrasonic, a photoelectric, and an accelerometer. And then we're using those values to determine how long we want to run or what we want to do with that information. An ultrasonic sensor, for example, can let the robot know that a wall, an obstacle, or another robot is nearby, and it can stop in reaction to that sensor. So that's how closed loop control can sort of be used in autonomous. Advanced programming resources. We do have a very, very long full FRC training course out right now. Beginner and advanced are each about 4.5 hours. We are working on some new training for January, so get excited for that. Hopefully be a little bit more digestible, a little bit less of a total day sink. But those are out there. We have a tutorial on sensors, an autonomous time movement tutorial. And again, feel free to reach out if you have questions. We're more than happy to help you guys out and answer them as best we can. I think that's all I have.
All right. So we're going to start the RoboReel giveaway in just a little bit in April. Thank you so much for this awesome information on vision and control. And so we're going to start the giveaway, and then we do have some Q&A, and also apparently you're going to have to explain yourself on something based on what one of our chatters have asked as well.
Uh-oh.
So So with that said, we're going to start the RoboReel giveaway. You do have to
No.
follow or subscribe in order to be eligible. So make sure you do that right now. This is the time, guys. Get everybody on your team in chat. The more people you have, the more chances you get to win. The more chances you have to enter as well. So April, with that said, what does everybody have to type in the chat? Hopefully they get the spelling correct on that.
This is a fun word. This was something we talked about earlier in the show during our vision. This was one of the steps we took to optimize that image, and it was called morphology.
So morphology is what you have to enter into chat at this time, guys. Morphology. So go ahead and get your entries in, guys, and we're gonna get that going in just a minute or two. But we do have some questions, and we're gonna kind of jump back to what you were called out on apparently, and I don't know anything about this.
I don't want to be called out.
Oh my goodness! So there was, I think it was on the
autonomous strategy.
So NATA. ASFTW, like so I'm just going to say that so I don't get it wrong, asks, pretty please call April on the example of autonomous strategies. She knows how to fix it, but it's definitely broken. So let's talk about it, April.
So this example kind of depends on how you have your motors wired to your robot. It's definitely something you're going to want to test. He's actually another engineer. He works here.
Oh my goodness.
This is the fun kind of banter you have at NI. They just call you out on a public web stream. It's great. Hopefully you guys can't see me blushing.
But
yeah, so you're definitely going to want to test your examples. A lot of our example code is largely correct, but definitely test things before you just throw them into competition code.
All right, that's fair. Enough grilling from your fellow employees, apparently. By the way, just saying, we have two more of these, so if you want to get him on something, him or her, I don't know who it is, but later on, we can always do something during a later show to embarrass this person. Just saying.
Have to look for something.
All right, next question we have from TK Chan 007 says, is there any way to use the simulator or use C++ / a Java robot in the simulator?
Yeah, so anyone who has LabVIEW installed can use the simulator. It comes default. You can open up a default robot project or one of our simulator-specific examples and run it in the simulator. It'll open all of that simulation window for you. You don't have to load anything special. It'll take a minute when you first run it. It has to go find all those VIs, but it'll do it all for you. It is LabVIEW only. There's no way to really run C++ or Java code in LabVIEW. So since the simulator exists in LabVIEW, your code has to exist in LabVIEW as well. But the idea kind of behind it is that hopefully teams that do program in C++ or program in Java for their competition robot can at least play with LabVIEW and play with the simulator and say, hey, this is actually pretty cool. This is useful. I can apply knowledge here. Because even if you don't use LabVIEW in your competition robot, being able to take this skill and learn it now so you have it for industry use later, so you have it for college, is a really, really effective use of some time you're spending after school in high school. So even if you're a Java team, even if you're C++, highly recommend, check it out, at least give it a try.
So one thing I want to mention, by the way, and we don't, when we talk about FIRST Robotics so much, we kind of forget about this, but this is stuff you can really use in industry, right? It's not like, the end goal is not just to learn this for your robot guys. We want to get you, prepared and ready when you're ready to go into your career path and career field as well. So keep that in mind. Everything that you do, this is stuff you're going to be using once you get out of, high school and college or wherever you take you. Look at April, right? She's working at NI right now. I mean, that's something that's just incredible to see, and so make sure you take this stuff to heart, honestly. Next question we have is from Hayden Port. What type of physics engine is the simulator based on?
It's a custom physics engine. It's fully integrated into LabVIEW. I believe we built it in-house, from what I know of it.
All right.
So.
We got two more questions I'll be able to see. One that just popped by me by Grease Monk. Are the updates to the Quick Start Guide going to be available before kickoff?
Yes. So the beginner presentation is already up on na.com/FRC. This will be up there tomorrow. Most of our content should be updated by kickoff. We're getting a brand new website. It's super slick. We are finally out of the 90s on our webpage. I'm really excited about it. So definitely check that out come kickoff. All of the documentation should be a lot easier to find. We put a lot of time and effort into making things easier for you guys, so hopefully it pays off. I'd love to see y'all's reactions to it in this and at kickoff when it comes live. But yeah, so all of our new content should be on there. These will be updated as well.
All right, and last thing we have, just a nice little comment that your sister Kim says hi, April, and is
Hi, Kim.
proud of you and watching you for this as well.
Hi, Kim. Hi, Kyle. Hi, Jenny. Those are my siblings. Kyle's the only one of us who ever is actually on an FRC team. But yeah. Hi, guys.
Awesome. All right, so let's do the giveaway. I think this is time. This is a good time to do it, right? So
I don't even have a Roborio.
You don't have a. I know you had a bunch of those Roborio.
Bare Roborio. It doesn't have a case anymore.
That's not what you're sending them, though, is it?
No. This is actually the Roborio. There was a robot at Michigan State Championships 3 years ago, 2015, that caught fire. This is the Roborio from that robot. It's totally functional. So that's cool.
And I know we do have a couple of questions. I might have missed a couple follow-ups. So real quick before we give away the giveaway, we do have a spot that if you want to ask more questions, you can do that as well. So I'm just going to put that up on screen once I find it. So we did just put up on screen. If you have additional questions, go to tinyurl.com/fundamentalq. That will be an opportunity for you to present more questions for NI as well. All right, I think we stalled long enough. Let's do the giveaway. Congratulations to OMC1223. Congratulations, you have won the Roborio for your team. So you got to make sure you shoot me a message with your shipping info. Just a heads up, guys, it will take about a week or so, maybe 2 weeks with the holidays around, so no guarantees by kickoff, but I'm sure NI will get that out as soon as possible that they can. So thank you, everybody, for checking us out. And April, thank you to you as well. I do want to mention a couple things before we take off today. Congratulations, OMC1223, for the Roborio giveaway. So we want to thank everybody who helps make this show possible. And, of course, if you want more firsts in your life, more efforts in your life, all we ask, if you like this show, if you like our other shows, go ahead and just let other people know about it. The more people know, the more people we can get on, and the bigger we can continue to make these shows and get some awesome people like NI to give away some amazing prizes like this. So thank everybody. And I do want to give a special shout out as well. Thank you, guys. We went over 2,000 follows today. So thank you so much. And over 1,000 YouTube subscribers. So cool day for us at First Updates Now. We're excited to be part of this growth with NI as well. Do want to give a big shout out and thank you to Annie Mark for the trivia prize giveaways, and of course a tremendous shout out to National Instruments for the Roborio giveaway. Hey, April, we got 2 more of these shows coming up in probably the next month or so, I think, altogether, right? So what are people to expect in the next month?
So the next show is going to go a little bit differently. We have a subsystem-based architecture for LabVIEW called Command and Control. We're going to go through that. How does that work? What does that look like? If you think normal LabVIEW for FRC is boring or you're too cool for that, come check out CNC. It's really neat. It's really sleek. I really like it. So we're going to be talking about that. And then the last one is going to be a little bit more mentor focused. So if your mentors are like, I don't want to listen to all this programming stuff, this is going to be how do you effectively teach programming? How do you teach LabVIEW? Sort of best strategies for talking to high schoolers, things like that. And we're going to kind of go from there.
Excellent. So we'll get to those dates soon. We haven't solidified those yet, but those are going to be coming soon enough. I do want to give a big thank you to everybody. This is going to be one of our last shows for the holidays. We are canceling our Finalysis show tomorrow, so I do apologize about that. More to come. We'll be rescheduling that at some point in time. We also do have our F4 CAD-a-thon coming up. So if you'd like to get more into CAD, we'll be doing a show for that on the 29th, I believe it is, a couple Saturdays from now. As I bring up my calendar. I'm sorry, the 30th we'll be doing that, but there are still registrations open if you're interested in doing CAD-a-thon as well. Maybe we have to do a Code-a-thon one day too, April. That'd be pretty fun.
Awesome. So we do challenges at Worlds at our NI booth. We were giving away Roborios last year, so if you want to learn LabVIEW and put your skills to the test, we'll be more than happy to see how well you do.
Excellent. We're going to look forward to that and look forward to more shows. Good luck to teams this build season. And thank you, April, so much for a phenomenal job once again. We're going to have more of these coming up, guys. Take care, everybody. Thank you for watching. We'll see you next time on First Updates Now. Talk to you then. Good night, everybody.